Well, today was the first day of the October 2022 HAARP research campaign. They're going to be doing a number of experiments for about a week. The first one today was a moon bounce experiment. It says a NASA Jet Propulsion Laboratory project in collaboration with Caltech's Owens Valley Radio Observatory and the University of New Mexico Long Wavelength Array, testing the potential use of HAARP for interior sensing on near-Earth asteroids. This experiment will reflect HAARP's transmissions off of the moon, and the echo will be received by OVRO and UNMLWA. Amateur radio enthusiasts are invited to listen to the transmissions echoes and submit reception reports to the HAARP facility, and it gives you information. Well, I got a number of waveforms, but I'm not sure. And then I saw someone who had a better idea of what was going on. They had a better signal. I got a real weak signal near the end of the. It only went from. It was about 11:30 in the morning my time. So the UTC time. I've got all the frequencies and the times and all this, and it was UTC time today. The 19th was 1630 to 1900, which local time was 1130 to 1400 my time. So I got a few of the waveforms, but the most interesting, I listened to the one person, and I have it on the Twitter feed, who was able to get a pulsing and the timing of the pulsing. And near the end of the effort here, just before they shut down the system at the reported time, I was able to get the pulsing. So I'm going to show you the pulsing first, and then I'll show you some of the other waveforms that I got. I'm not sure if those others were HAARP. I think possibly this one is. Now, my signal strength is nothing like the person you're going to see on my Twitter feed, but I did get the HAARP signal, I believe, the moon bounce, and they were broadcasting at 9.6 megahertz, 9600 kilohertz. So that's where I've got it set, and you're going to see and hear. It's going to be a very weak signal, but you can physically hear it pretty well. So let's go check it out. I've got it pretty narrow. I've got the CW filter on there. The other individual had a wider selection, so you could actually hear the sweeping on his. You could kind of see the pulses on the waveform itself, and then this is the audio portion. You could hear it's decoding, but yeah, so it's a very weak signal, very weak here. I'm in Oklahoma, and my setup here, I've got an SDR with a wire antenna with a coil on the end, but you can see the signal itself at the prescribed frequency, 9600 kilohertz, 9.6 megahertz, so it's coming in at the right frequency. And this is the end, just about 2 minutes near the end of when they're going to shut it off. So I'm just going to let it play until they shut it off. But yeah, the other signals I've got, I'll show you that too, which I'm not sure if they're HAARP or not, and if it came off the ionosphere or if it came off the moon. This one, I'm not sure if it's bouncing back off the moon or if it's reflecting off the ionosphere. But you can, I'll shut up here so you can hear. So that's actually a longer pulse, but because I've got the CW filter on, it just sounds like a shorter pulse. This is the first day of this HAARP research campaign. And they're supposed to be shutting down here about this time, and the signal will stop, showing probably a shutdown. There you go. That was the final. And then the signal didn't come back on after that. And it was right around the prescribed time, within probably about 1.5, 2 minutes, when they were supposed to shut down for the day. So that kind of tells me that's HAARP. Now let me show you some of the other signals I received earlier. This was at the end of the campaign for this day on this mood bounce experiment. Now this one was one of the first I received. It was about a little while, just a little before HAARP was going to be starting the experiment. I thought maybe that they turned on the transmitter, and it's a little bit off frequency from 9.6 MHz. But this is what this one sounded like here. Let me play this. And you can see it coming up right here. So you can, it's right a little bit off to the, shifted to the left a little bit. About 95, 98 and a half or so. But it did come up and it does fade away. So I'm not sure if this is HAARP or not for the experiment. They might be, maybe they're, turning on the transmitters, making sure they're going to transmit. I'm not sure. Like I said, the first one I showed you, I think pretty much that was probably HAARP with the moon bounce experiment. You can see it's getting stronger, which is an indication of propagation. And I don't know if it's bouncing off the moon or off the ionosphere. Now I've got it on upper sideband. Now see, there it went away. If they stop, you turn it off. So that's that one. Let me show you another one that happened a little bit later on. So this one's going to be one that I got a little bit later, but before the end. And you're going to see propagation, the fade in and out. So it's bouncing off the ionosphere, or probably not the moon, but let's try this one. Let's see. But it's really near the frequency HAARP was going to be. Like it could have been off a little bit, You can see it fade in, fade out. Here's where the pulsing was over here, and this has shifted a little bit, and it kind of fades away. So it just didn't come back on after that. So were these HAARP signals? This one, the first one I showed you, I'm replaying it again. It might be, because it matches up with one others has a longer pulsing. There's your signal. You can actually see the wave form there, the received wave, the received frequency, and then you can hear the audio of the pulses. But I don't know. This one was a little bit tougher. That Ghosts in the Air glow that's coming up in a couple days, that's going to be the better choice, because Amanda, she really knows. She puts out what's going to be happening at what time, so you know what to look for. And it's different wave frequencies, it's different transmissions and all that, so we'll see. But hey, I don't know. Was this HAARP? I don't know. Maybe.